Our next example is a test for variance. So what we're looking at here is the variability of each of those two samples the same, or is it different? So we're considering the variability here, how much these spread out. Now in this example, we're looking at an evidence of a difference in variance down here, a difference in variances. So are the variances equal? If the variances are equal, we've written here town 1 and town 2, equal variance, as opposed to unequal variance. Now these variance tests are the first that we've used now, which do not have symmetrical distributions. This F distribution is a distribution that we've seen has 0 on the left-hand end and large values on the right-hand end. It's an asymmetrical distribution. But in order to find our critical F value for using in a problem, we can either use Excel or tables. Now on this course you're just going to use Excel because there are, as you saw in yesterday's lecture, there are a large number of F distributions and they're based on the degrees of freedom and the alpha values. So we'll be using just Excel for finding critical F values. And the critical F value depends on degrees of freedom. And if you use this to remember the F statistic, we are considering the larger value of the standard deviation squared, so larger S squared value, divided by smaller S squared value, so that we only need to consider the right-hand end of the distribution. And the further away our value is from 1, the more likelihood we have that the variances are different. So our distribution here starts at 0 and is skewed right. So we're looking for the critical F, and that critical F is not just related to alpha, it's also related to the numerator and denominator degrees of freedom. In a fraction, the numerator is the number on the top line, and the denominator is the number on the bottom line. So when you're looking for numerator and denominator degrees of freedom, it's the numerator degrees of freedom is related to the sample minus 1, sample size minus 1, for the sample which had the larger standard deviation. So the larger standard deviation in this example was from the sample of size 26. So 26 minus 1 gives the numerator degrees of freedom. The smaller standard deviation comes from town 2, and that had a sample of size 21. So the numerator degrees of freedom is 25. The denominator degrees of freedom is smaller sample minus 1. So these are linked, sample sizes are linked to which is the larger sample standard deviation. Sample size of larger sample standard deviation is on the numerator. And the sample size for the smaller standard deviation, minus 1, of course, will be the one for the denominator. So we get our critical F value from Excel by using the FINV button. FINV, use the alpha value, degrees of freedom for the numerator and degrees of freedom for the denominator, and you can get that straight from Excel. So the value we've got from Excel here, critical value, 2.07, and that's what we'll use in our test. So let me just write that on before I forget. That critical value from Excel, remember this distribution is very skewed and starts at 0. So our test critical value there depends on 2.07 with the alpha value on the right of 0.05. Now just because we use the value on the right hand side doesn't mean there isn't a rejection region on the left hand end as well. That rejection region we're not going to be concerned with. It's a much more tricky calculation. So going back to the hypothesis, sigma 1 squared equals sigma 2 squared, because we have 1 and 2 meaning town 1 and town 2, alternate hypothesis, sigma 1 squared is not equal to sigma 2 squared, so those are the population values. Alpha value here is 0.10, not 0.01, 0.10. So we divide this by 2 to get 0.05 at each end. Numerator degrees of freedom is 25. Denominator degrees of freedom was 20. Sample size is -1. The F statistic here, larger S squared divided by smaller S squared. And of course our S squared values, standard deviations were 30 and 20. So 30 squared divided by 20 squared, 900 divided by 400, that's 2.25. And what we're saying here, 2.25, clearly is in the rejection region. So it would be somewhere in that blue spot, which means we reject the null hypothesis, reject H0. Since our test statistic is in the rejection region, it's bigger than that critical value. And this means we have evidence, sufficient evidence to claim the alternate hypothesis is true. So sufficient evidence at alpha equals 0.1 to suggest there is a difference in variation. Remember, variation, variability is all linked to that spread measure. Difference in variance or variation in weekly energy consumptions between the two towns. So this is where you go back to the information in the problem and write the conclusion in the context of the question. And that's it. Sufficient evidence at 0.1 for alpha to suggest there is a difference in variation in weekly energy consumption between those two towns. And that's all for today. So after this, you should be able to see how we do an F-test for variance, use Excel to perform that test, and we've been looking at 2 samples. More about that next week.